So, like we've chatted before, this session's about observability and Sitecore. So, observability is one of those newfangled cool things that everyone's kind of talking about in the tech world. So, we want to talk about it in context of Sitecore. So, for those of you who don't know who I am, my name is George Chang. I am a Sitecore MVP. Uh, and my day job is working as the director of digital marketing services at SUGCON. So you can always find me uh, with my terrible posts on Twitter at George Chang, or trolling around in Slack at the same. So first, to start out, we're going to talk about what exactly is observability, and I think for most people who Google like what is observability, one of the very first things that they encounter is that uh, it, it's just monitoring, right? And that we all monitor our applications. So spoiler alert, it's not monitoring. It's more than monitoring. So the official definition of observability is the measurement of how well the internal states of a system can be inferred from knowledge of its external inputs, which is a really fancy way of saying we should be able to see how well a system is working by looking at the stuff that it puts out, right? I kind of put this in what I call George's maxims on observability and life in general. Basically, you can't improve what you can't measure, and you can't measure what you can't see, right? So, in order to have the maximum amount of measurement and improvement, we've got to be able to see as much as we can into the systems that we're working with. And in this case, this is Sitecore. But at the end of the day, observability really, the improvements is one part, but the big thing is the big output for observability is really this, which is reliability, right? We all want reliable software, reliable sites. This is nowadays reliability is not just something that we expect from sites, but it's actually considered a feature of a site. How reliable it is, right? I feel like in the past few years, the talk about kind of site reliability engineers and SLOs and SLAs and things that like have really kind of come into the forefront of software that we deliver, because these all have business impacts for our customers. So reliability, that's our big thing. So when we speak about observability in software, basically we have three main pillars that we're looking at as far as what we want to see out of our software, right? So the first pillar is metrics, second pillar is events or logs, and the third pillar is traces, or some people will refer to this as melt, right? This is the acronym for each one of these things. And these are kind of the major components that out of any kind of software system that we want to see, but especially in Sitecore. So these three kind of what these three pillars actually are, right? Metrics, these are quantifiable measurements, right? These are things that you can actually associate a number to: how much CPU you're using, how much memory you're using, things of that nature. Events and logs, right? This for every developer is pretty obvious, right? Like we log things to a log file. Sitecore logs things to log files. Solar logs things to log files, right? OSs send events to the event log. These are just messages output by processes or systems. And then traces are more related to requests moving through your system, right? This could be data that moves from your application to your database, or this could be network calls within your application. It's kind of following where that data goes and the steps that it takes to go through your system. But the one big thing about observability is we know the times, right? And we kind of understand this with logging a little bit. We do every log message is time stamped, but the big thing is being able to have an expansive time and be able to see kind of what happened during this expansive time. And so a lot of the observability repositories are what's called time series data stores or databases, right? You'll see them labeled as TSDBs. And basically these are just databases that are optimized for time span data, right? So things that have a timestamp on them, they're optimized to handle that kind of timestamp data. This is important, right? Because we have all these things. We have logs from various services. We have CPU usage. We have memory things. By kind of getting everything onto the same page as far as what time things happened, we can correlate a lot of that information, and we'll look into that in a little bit more detail. But at the end of the day, right, I think a lot of people see observability as, well, to make my system more observable, I'll just log more messages, right? And really the logging part is only one part of it, right? At the observability is really how much of your system you can actually view, but we want to see more than just logs, right? There are things that that are part of your system, that are part of your solution, that logs may not cover. And I think one of the most common, back to this whole idea of monitoring, like one of the most common things that we talk about with monitoring is uptime, right? So during a time span, right, we'll have you may have health checks that run, that ping your site. Hey, the site is up. Hey, the site is up. Hey, the site is up. Hey, the site is up, right? And then all of a sudden the site is down, right? And then it's like a fire that everyone is basically just running around like chickens with their heads cut off. Now what do we do, right? The site is already down. We didn't get a good opportunity to see. We had no idea, right? It was green, and then red. There was no yellow. There was no warning, right? Like site is up, site is up, site is down. So this is what we want to avoid, right? We want to be able to kind of look at the trends, have the data to be able to catch any issues before the crash happens, right? Before the red light happens. So we need a little bit more information than just whether the site is up or down, right? So let's look at this with a little bit more data. Okay. So this is all kind of made up data, but let's say this is our memory usage. Looks pretty good, and then all of a sudden it spikes up really high right before it crashes. Okay, something memory wise was not there was definitely a problem with the system that ate a lot of memory, right? Okay, let's take that same time period, let's overlay so this is kind of where we want to be looking at, right? We're saying, hey, we should really investigate this period of time because this is where we saw the spike, right? And also we may want to look here, right? This is where the spike starts to happen, really starts to really start going up. Maybe whatever happened here is really the cause of the issue. We can look at that, right? Now, if we overlay, maybe this is our CPU usage, right? So we see our CPU usage it's okay, it spikes, and then we see it spike up really high before it all crashes again, right? And now with this next layer of data, we have this point. Hey, maybe something happened even before this point right here that caused the CPU spike. Maybe this is an area we need to start investigating, right? Maybe this is the source of the issue. Now let's layer yet another layer on here. Let's say this is our graph of failed requests throughout the application, right, between our services. And now we see our failed requests actually started here, where maybe our CPU and our memories already started looking still look pretty normal, but the failed requests are already starting to happen, which means some error happened, which means we need to investigate. So really, instead of investigating kind of here when the activity actually happened, right, there's other points in time that we can kind of go back and see, like, where we can kind of pinpoint where things really started going wrong. And with Sitecore, with any other application with so many services, it's very easy for a service to go down or have some issues and cause more kind of catastrophic results throughout. So what can we do in this kind of situation? Well, this is where some of the alerting can come in, right? How do we prevent these types of things from happening? How do we catch some of the red flags before your site or your solution really has an issue, right? And so this is where we can do some alerting. So let's say, this is a great place to do some alerting. This is where some of the failed requests are starting to go up, right? Um, this is we're having kind of an elevated CPU that's a little bit more than what it was previously for a certain amount of time, right? This is where alerts need to start firing to let whoever, right, whether it's a developer or operations person or infrastructure person or whoever, to know that, hey, something is going on with the site, and we should probably do some investigation. So you start looking at this time period, right, in the red box, rather than the time period when your site actually goes down and it's a little too late, right? So it's almost kind of reading the tea leaves a little bit in the stability of your application. So what kind of tools can we use to do this kind of measurement and this kind of this kind of data tracking, right? So the data pipeline for tools basically kind of come in three steps, right? One is an aggregation and transformation of all the data that you're coming. You have all these aggregate systems, right? Sitecore is one of them. Solar is one of them. Your databases are one of them. If you're running Solar and Solar Cloud, you have Zookeeper. You have the actual monitoring tooling itself, right? You can monitor your monitoring tools. Even if you have other systems outside of Sitecore, you can pull data in from there too. But the idea is to pull as much data from all the various sources as possible, store it in a repository, right? And then have visualizations on all this data. So that you can kind of see when things are starting to fail, and then kind of alongside with visualization, there's also this piece of alerting that comes along with it. So how does this translate into an actual application like Sitecore? Right, so we have our application here on the left, and kind of basically for each tooling, there's an endpoint or a client library or an exporter that's part of, there's a C# library that you would be able to use in your application, for example, right? And that, sends my traces to one of those time series databases, right? Or it provides metrics based on an endpoint, and the time series database scrapes that endpoint, or I have a log exporter that for a particular tool that exports to a log repository, right? So, and then basically these are the repositories, and then you have visualizations, graphs, charts, log visualizations, things of that nature that pull from these repositories. So for those of us who kind of have worked in software for a while, one of the things that will definitely stand out to you is we have very tight coupling between kind of these SDKs and libraries and things with our application, which is always a little bit scary, right? So let's say, we want to switch out what the source of our log repository, right? Let's pretend we were using some NoSQL database, right? And now we want to start putting our logs in an Elasticsearch database or Elasticsearch repository, right? So originally our log exporter was, had its own things in there that would push to our NoSQL database. We want to swap that out, right? We have to wind up going in, stripping out the log exporter, putting in our new log repository, which could be Elasticsearch, for instance, right? Get the libraries for our new log exporter, compile our application again, deploy it, and then finally we're connected back up into our new log repository. And so because the way that all this tooling works, right? They're trying to cover the largest expanse of languages and platforms and everything. So there is a pretty close tie with your application and your exporter. So one of the big things that's been kind of happening in the industry right now is this thing called open telemetry. Basically, this is an open source, vendor neutral, kind of standardized format, right? To kind of solve this problem, because this isn't just a problem of one tool. As the amount of observability tools grow, um, becomes a bigger and bigger problem. So basically all the industry people got together and said, hey, we should just standardize on something, and that way we don't have to deal with this, right? So it's currently in beta. It's very still kind of early stages. I think they just released their 1.0 specification of how to collect metrics or something, but it's definitely something to keep an eye on. It does actually work. There is a .NET library that you can use to start pulling telemetry from your application, uh, to be used with open telemetry. But the idea is that you would have these open telemetry libraries, right? That's in the gold, that's part of your application, and they would go to these collectors. But then these collectors have services that push to the back end, right? And these collectors know who to talk to and be able to talk to, and these vendors basically supply uh, endpoints or libraries or whatever for open telemetry to be able to collect that and push them to their backend, right? So now that this data flow, looks more like this. So we have our open telemetry libraries here into an open telemetry collector, right? We still have our time series database and a log repository, but now if we were to change out our log repository, it really is just changing out our log repository, because it's something that open telemetry knows how to talk to, right? And integrating something like open telemetry is super easy. It's literally a couple of lines of code, or if you really like really long lines of code, it could be one line of code. But here, as an example, right, this is a initialized pipeline processor in Sitecore that adds the ASP.NET instrumentation libraries. That's automatic instrumentation for all the requests, that the tracing that goes through ASP.NET. Um, it's already kind of built into the platform, so this is kind of piggybacking off that, and then adding an exporter to an open telemetry collector and putting it out there. And this is all you have to do, right? Literally like initialize it, and then it handles the rest. So it's very easy to integrate and implement into your application. So that's kind of open telemetry, but what about all those backend systems, the time series databases, the collectors, the visualizations, right? So there are several tools kind of in the market today. I say market, but most of these are kind of open source. So the kind of the granddaddy of them all is the Prometheus stack, or you'll see it referred to as the Prom stack. So Prometheus here serves as what's that time series database, and then Grafana is kind of the visualization tool. And you'll notice that there's not really anything to handle for logs. Grafana, probably like a couple of years ago, came up with this product called Loki. Basically, it's a log store, and they call it the Prometheus for logs, but it's a glorified way of just storing all your logs in there and being able to visualize all that through Grafana. The other kind of big player in the game is the Elastic Stack, or you'll hear it referred to as the ELK stack, right? Elasticsearch, Logstash, and Kibana. These are all open source, but Elasticsearch basically acts as your repository. Logstash kind of acts as your aggregator for your logs, and then there are and your metrics kind of come through there as well. And then Kibana is your visualization interface. So there are a couple of options as far as this goes. Kind of just as we're talking kind of vendor agnostic or platform agnostic. Other things that get talked about with observability is APMs. So these are kind of your Datadogs, your New Relics, your Dynatraces of the world, right? Many of us already kind of use APM platforms. So this is just another layer of data that comes to you. So this is data more involved with your actual application itself, right? Hey, my application throws an error. Let's that may go through our application performance management system, and not necessarily picked up through a log or whatever the case might be. Also, there's distributed request tracing, uh, which is basically tracing requests through kind of a microservice environment, tracing those requests from service to service. And then there's also things like service meshes as well that help along with this. So this is all good, right? This is all stuff that we can install on our servers and do everything. But we can't get by without talking about the cloud. So basically these are tools that we kind of use already and we don't really realize it, right? Things like Azure Monitor and application insights, if you've been working on Azure, are very commonplace things that you have application insights kind of acting as that APM, and Azure Monitor is kind of the everything else. AWS has their own CloudWatch and X-Ray products that basically do the same thing. And then you have these third parties, right? You have these kind of legacy APM companies like Datadog and New Relic kind of getting into the cool observability space. You have some of the newer kind of kids on the block, the startups, Honeycomb, Lightstep, right? That and kind of help enhance the observability experience and provide a lot of support there. But basically, hey, basically everyone on the screen is saying, hey, you can take your data, dump it into the cloud, we'll handle the rest. So lots of options, but there is a little bit of bad news, and this is definitely something that if you've seen me on Twitter in the past maybe a month or so, you've heard me complain a lot about, and which is not necessarily a bad thing, but everything is Linux first, and that really stinks for those of us who are using things on the ASP.NET framework, right? Hey, we don't support Windows containers, Windows has this problem, they don't support this, we haven't tested it, et cetera, et cetera. Given that most servers in the world run Linux, I can see why this is the case. But I mean, it's just basically just be aware that Windows is very much a second-class citizen in this space at the moment. There are definitely steps to make it less so, but June 4th, 5th today, 2021, Windows is very much kind of a second-class citizen in this world. That's okay. There are some things that we can kind of tweak to run in Windows. One of the big things with observability, especially things like Kubernetes, is being able to kind of run a container to pull all your metrics, and this requires something what's called privileged containers. Basically, it's like admin access containers that have a higher level of access to be able to pull the metrics from your or from the servers themselves, CPU usage, memory, and things of that nature. Things that don't, normal containers can't do. That's slated for Kubernetes 1.22. So not something that we can take advantage of just yet. And then also, most all those containerized things that like tools that we talked about, Elasticsearch and Kibana and Prometheus and everything, there are no Windows containers for those. So if you want to use them in a Windows container situation, I built a bunch of them basically just to see if I could, and they work. So they're all on my GitHub. They're all Docker files, right? And you can kind of build your own Windows container versions of these tools to use. So enough about observability in general. Let's talk a little bit more about kind of Sitecore and how this is more applicable to the Sitecore space. And so it winds up being that Sitecore is desperate for observability, right? One, there's a lot of roles. And there's a lot of logs. A lot of roles generate a lot of logs. Each role generates their own logs, right? And then there's a lot of customization. There's a lot of work that no one installs Sitecore as is and then deploys it out. So, there is always customization and development work on the Sitecore platform. That flexibility is kind of one of the key parts of the Sitecore platform, but it also opens, it's kind of a catch-22 situation where you have a lot of options for customization, but at the same time that provides a lot of openings for a lot of bad things to happen as well, right? So going to this whole idea of lots of roles, just kind of out of curiosity, I wanted to see how many roles, right? So Sitecore has one of these has architecture diagrams, but I mean, in an XP1 environment, just the XP1 on its own, you've got 14 roles, plus if you have running a distributed Solar and Zookeeper, you've got 2 more, plus SQL Server and Redis, you got 2 more, and then all the other kind of bits and pieces of Sitecore that can add on, like Horizon and Publishing Service and the XM. So you do wind up with a lot of roles, and each one of these generates its own logs and metrics and things of that nature. So it's a lot of chatter, which in observability world is great because that just means more data. So because we have all these roles, right? And this is actually very much ripe for Kubernetes and something that Sitecore is kind of slowly, well, I shouldn't say slowly, quickly moving towards, actually, with, there's been the kind of back and forth with the deprecation of app services and everything, but basically Kubernetes being kind of the future of Sitecore in the cloud, right? And for those of you who aren't familiar with Kubernetes, that's okay. One quick one-slide crash course. Basically, it's a container orchestrator. So basically, all it does is handle all your containers, right? It knows when to spin them up, knows when to spin them down, knows when to connect one to another, et cetera, et cetera. If you're, usually you want to use one of the cloud hosted managed instances, right? Like Azure Kubernetes Service or EKS from Amazon. If you're really brave, you can install your own Kubernetes on the Metal. It's not a lot of fun. I've tried it. But one of the cool things with Kubernetes is that you can run Windows and Linux workloads together, which is really great because back to the whole, like everything is Linux first. Now you have this option of being able to run your Sitecore applications in your Windows containers, and then do your kind of the Linuxy observability tools, right, that are kind of more Linux native, run those in Linux containers and have them all kind of work together and all nicely and happily, right? And lastly, Kubernetes is the kind of the Sitecore preferred green check mark way of deploying to the cloud. So with the world of observability, Kubernetes is really nice, right? And here's the reason why. So in Kubernetes, you have this. You have your nodes, which are kind of basically your physical machines, and then your pods that are holding, some sets of containers, right? And then what Kubernetes provides, and actually this is the service that those managed instances provides, is what's called the control plane. And basically this control plane is the brains of the whole operation, and this is where the magic happens, right? And so you can almost look at control plane as kind of the butler for your Kubernetes instance, right? It knows how many nodes there are, it knows what resources are being used, it knows when pods are created or destroyed, it knows how many pods are in each node, what how much CPU and memory each container is using, et cetera. It knows all the various details, right? And the reason why is because every time you want to deploy something to Kubernetes, you say, hey, control plane, Kubernetes Jeeves, go create me a pod with 3 containers with these images, right? Or go create me a network endpoint with that ties to this container or that container or whatever the case might be. So the control plane knows all this data, which is great. This is a great source of data for in terms of observability, right? So this enables things like auto discovery, right? So whenever you spin up a new container or a new service in your Kubernetes cluster, right? The control plane knows, right? So the control plane can detect those changes in this configuration. It could automatically go basically attach all the goodies that you would need to run to metric or to monitor your containers from an observability perspective and send them to your observability tools, right? So very little actually has to be done from a development standpoint. So you can have multiple distributed teams. They're all building applications, right? They're just deploying to Kubernetes or deploying to Sitecore. I may have a headless application that I'm running with the headless SDK, right? I may not have put in necessarily the some of that kind of initialization code in my my application itself, right? But because Kubernetes knows it can basically detect kind of when your application gets deployed into Kubernetes, your headless application gets deployed into Kubernetes, then it says, hey, go scrape this container for data, go hit this endpoint for data, go, go see how much CPU memory this is using, et cetera, et cetera. And so it's a very low barrier of entry for developers. They're not worried about how do I send my metrics out. It's very much something that is handled by the system itself. All right. So enough talk, enough slides. Let's talk let's kind of look at a couple of things that these tools can provide, right? So first off, let us take a look at some of the pretty charts. So this is a Grafana instance that I have running on a basically an XP1. You can see all the pretty containers that are running, all the pods that are in here, right? So um, this is all in AKS right now, but we have in a full-blown XP1 deployment. We have Prometheus running. We have Grafana running, and we have all the goodies. It's a lot of pods, and so this is where kind of the monitoring comes into play. But so this is Grafana that's running in the Kubernetes instance. This is running on one of the Linux nodes, and it's a very nice interface, but basically you can see a lot of the data that you can get, right? So these are some of the metrics that can come. Grafana can pull from a number of different kind of backend data sources, right? So this one actually is pulling directly from Azure Monitor. This is that whole everything is Linux first, so we can't. It's very difficult to pull data so directly from the clusters, from the Windows nodes. So we can pull data directly through Azure Monitor, so we can see kind of CPU utilization, memory utilization. We can let this run live. Um, you know, a ton of data, right? Down by the instance, right? My Sitecore namespace is running how many pods, right? My Sitecore namespace is using how much percentage of the CPU, which right now is very little. Our memory utilization, right? This is all a ton of data that you can kind of look at and start making decisions on, set alerts on, things of that nature. Um, and then from inside Kubernetes itself, right? This is the cluster itself, so you can kind of see, more charts and graphs. You can kind of see how much CPU is kind of requested by each pod, and how what the limits are, and how much it's actually using, and so you can kind of be able to scale your solutions this way as well. So you get a lot of data, and then there's the ability to create alerts, right? And then, so kind of back to that original made up situation that we have, we can use this data with these time spans, right? And be able to, you know, in the cases that something catastrophic does happen without us catching it, we can kind of go back in time and see, tie everything together to see kind of what happened, right? But at the same time, be able to set alerts for like, hey, in the past 15 minutes, if my CPU usage is over 20% and or 40% or whatever the case might be, and I have more than an average of 18 failed requests, send me an alert, right? It's just proactive monitoring that we're looking to do here, and in order to do that, we really need basically as much data as possible. And through here you can do things that you can actually see the all the data that's coming through, right? So here are my sources. I have Azure Monitor and I have Loki. So basically all my Sitecore logs come through here. Let's see, if we look at our Sitecore namespace, right? This should look familiar because these are all Sitecore logs. And you can kind of see how many logs happen at what time. You can run them live. But basically the idea is, we have the time where everything happens, and we can run queries here and see exactly what happened at what time, and correlate all that together to really kind of find the root cause. All right. So with that, that's kind of the demo in a nutshell. So basically, kind of in conclusion, right? These are kind of the key points that we really want to talk about. Is, why do we have observability? Why does it exist? Right. One is the more observable we make our system, that means the more data that we get. And that means the less time we can spend problem solving, right? Because we have all this data, we have all the tools that we need in order to solve our problems. It's a lot easier to solve a problem when you have a lot more data than trying to solve a problem with no data, right? So the more observable your system is, the better it is for everyone. With things like the auto discovery that Kubernetes provides you, or some of the other tooling, it doesn't have to be Kubernetes. Some of the other tooling actually provides very good kind of auto discovery capabilities. Very little code actually has to be changed, right? There may be the initial kind of setup for metrics endpoints and understand, a little bit more logging, or whatever the case might be. But it's a pretty low barrier of entry considering the benefits that you really get from it. Um, Kind of what we were talking about earlier, like observability is really one of the, it's like just now becoming cool. Even though it's definitely something that has been in the industry for a long time, but not only is it, I guess, just now being cool, but now there's a lot more tooling and services and everything that's kind of being provided for it. People call it like APM 2.0 or APM 3.0, but but a lot of those tools are still kind of in its infancy, like the really fancy stuff, right? And if you're deploying to the cloud, really Kubernetes is the way that you want to go about this, given that it provides all these benefits. It's the way that Sitecore is pushing into the future, and it makes observability super easy because it shows you so much stuff already. And of course, lastly, I have to complain that Windows container support is occasionally, and by occasionally always, a complete dumpster fire. Uh, that's what we have learned. So, you know, hopefully we'll get to a better place there. With Windows container support just in general. All right. Um, some links. Feel free to pop in. This is kind of all the random stuff that we've talked about: Prometheus and Grafana, Elastic, Open Telemetry, blah blah blah. And that is it. So if you have questions about this or anything else kind of Sitecore related, you can always find me on Slack. You can find me on Twitter. Don't read my tweets unless have nothing better to do. But yeah, happy to answer any questions related to kind of observability, all the learnings that we've had, and kind of implementing observability into a more enterprise solution, and some of the kind of benefits and metrics that we get as part of kind of understanding the system as a whole, and some of the headaches that we've minimized because of it. All right.
Thanks, George.
Of course. Let me find my window here again.
George, was good. We do have a question in chat.
Yay!
So I will actually, I'll work out a way, and we're going to highlight it on screen. It's from Jeff LaRue, and he says, have you tried the Windows Docker Engine experimental mode to run Windows and Linux containers simultaneously? If yes, did you encounter issues with observability tools?
Yes, I did. And yes, I did encounter plenty of issues. Yeah, it's some things work okay because it's these observability tools are so much dependent on gathering metrics from either your host systems or other containers and things. This is where that Linux containers on Windows functionality, that hybrid way, just doesn't have the it does not handle that well at all. I think if you're running kind of more basic applications on that, it's okay. But because of the need for these observability tools to kind of reach out and get all this data, it doesn't do so well with it, unfortunately. Therefore, all the Windows containers.
So, George, can you expand on, you mentioned Windows containers were a dumpster fire. Can you elaborate on that?
Oh, where do I begin? So I mean, I can tell you for one thing, one of the cool things that I wish we can pull into the Sitecore world from a just kind of a general kind of cloud native / observability perspective is something called service meshes. And the idea of a service mesh is that basically you in kind of cloud native world, at least, that you have you can run these sidecars containers along with all your other containers, right? So you have your CM container, and then you can run a sidecar container, and basically everything, all your data that kind of comes out of your CM or your CD container kind of flows through this proxy. And with that, you get a lot of data out of it, right? You can get latency data, you can get whatever data. Windows container networking is garbage, and therefore it can't do things like this. All this work kind of depends on things like Linux IP tables and all the cool stuff that Windows doesn't have. I've been kind of reading rumors and trying to find insiders to see kind of what the future of this is, and I think they are trying to build some of this type of stuff in there to make Windows networking and Windows containers a lot better. But at the end of the day, Windows containers are really kind of, at the moment, they're really kind of a stopgap measure, and please don't send someone to murder me, Microsoft. I'm sorry.
Thanks, George.
Yep.
Thanks, George. I'm having trouble getting my camera going.
I mean,
is that VCam? Is that you? Is it?
I know. It's too fancy.
So, word on the street is, Bruce, what are you doing out there? Painting your deck?
Apparently, actually, I've just been sitting on my chair listening to George. That's great. Yeah, the Linux thing's a bit of a pain, isn't it? It got me started on a quick, that's a great idea for Docker, and I went scuttling off to investigate that, and I came across exactly what you're talking about. Example of how that support's not really there yet for our Linux and Windows alongside.
Yeah.
So, interesting topic.
Yeah, you see all the cool things that everyone else is doing. You're like, I want to do it too, but you can't. One day.
One day I'll have to restart my webcam. How do we do that?
Technology holds no mysteries for you, Bruce.
I really think it's crashed. It's a case for Control-Alt-Delete, guys.
Some nice feedback there. It's Rodrigo, Jim, Dylan, Madry, thank you. Have you got that video, George?
I'm sorry?
G Tucker.
All right.
G1. Have you got that video?
I'm just lining things up.
Okay. Looks like we're low on questions. G2.
All right. Sounds good. Well, if anyone does come up with anything, let me know. You know where to find me in the usual channels. And with that, I'll see myself out.
Thanks, mate.
Thanks.
Now is the time for solidarity in the face of this threat to all of humanity. I implore leaders to stand together and heed this appeal.